can check the body temperature. Okay.
Wait a minute, sir.
Alright.
It says here the body temperature was 30 degrees Celsius.
Oh, 30 degrees Celsius. So I think we need to determine the time of that. So let's go.
Okay, before we continue with this video, let me give you a little bit of an introduction to the Newton's law of cooling or warming, but in this case we're using cooling. So, Newton's law of cooling states that the rate of change of the temperature of a body is proportional to the difference between the body temperature and the temperature of its surroundings. Okay, as you can see here, the model is expressed as d capital T over d lower t equals to k multiplied by t minus tm. So in the course of the video, one of our forensics will tell you what exactly is t and what exactly is tm. But I will tell you what exactly is d capital T and over d lowercase t. What that is the rate of change between the two temperatures, rate of change of the temperatures, and T over Tm is basically the difference between the temperature of the object, in this case the dead body's temperature, and the difference between that and the surrounding temperatures. And K is the constant of proportionality. Anyways, from this model itself, we can integrate both sides, and as it's shown here, integrate 1 over T minus Tm, which is the difference between temperatures, dt equals to integral K dt. So by doing the calculations here, we'll be able to get the general equation that will be used inside the video later on. Anyways, that's all for me. Thank you very much. Please enjoy the video.
So, Iskandar, how do we do to figure out the time of death for this body?
Yes, to figure out the time of the death of the temperature, which is we need to apply one of the subtopic from additional differential equation, which is the Newton law of cooling. So we will use the Newton law of cooling. So the general equation is T equal to A to the power of KT plus Tm, which is Tm is the surrounding temperature, T is a body temperature.
Okay, so after we find the general solution, we can do the table for to figure out what the ratio. So 0 is represent of the time we found the body, and 32 degrees Celsius is the degree of the body temperature for that time. Same goes to 2 and 30 degrees Celsius. So after that, we will substitute the 0 and the 32 into the equation. So after we substitute, settle down, and we get A equal to 5. After we get A equal to 5, we substitute into the general equation A E K T plus Tm. So Tm is surrounding temperature equal to 37. After that, we substitute the second equation. For those who don't know, the E to K equal to 3 over 5. We put the long into the both of sides to eliminate the exponential, and then we get the K equal to negative 0.2554.
So after we find K, which is negative 0.2554, we substitute into the general equation, which is T equal to 5 e to the power of negative 0.2554 plus 27 equal to 37, which is 37 is the normal temperature of the body. So we substitute the negative 0.2554 into the equation, and we will get e to the power of negative 0.2554 t equal to 2. So after that, we learn both sides, and we will get negative 0.2554 t equal to ln 2. And to find the t, we need to divide ln 2 divided by negative 0.2554, and we will get t is negative 2.714. Since the negative sign negative is mean that the time of death is before the time of we found the body of the dead. So we will times 2.714 by 60, and we will get 163 minutes. So we will subtract from 4 p.m. subtract 160 minutes, and we will find the time of the death. So the time of the death is 1:17 p.m. I guess we are done.
It's supposed to be dead.
What? I want to do a conclusion. Okay, usually our forensic expert use Newton's laws, cooling or warming to determine time of death. Other than that, we also use in our daily life. As example, we use Newton's law, cooling or warming, to determine how much time the hot water turns into warm water.